Okay, I just wanted to go over the first discussion board post. I normally don't make the videos. I usually just post the solutions, but if you do have any questions, I'm more than willing to make videos. Just have to let me know. All right, so going into here, and I know you're only supposed to do 11 through 22, but while I have it open, I will go ahead and offer explanations on other things. All right. I'm not going to do number 1 because it's already posted and I don't feel like reading that to you necessarily. On number 2, difference between macro and micro, know that the A in macro and micro, the I, are really what distinguish the two words. That's the only difference. If you notice the course, the way the course is set up, if I can find it, go to the front page, each of the macro and micro questions right here stands out. Macro means all. So this is a class about the economy as a whole. However, we do have to study micro to get there. And I has to do with individual, and it could be individual people, individual industries, or an individual good like apples and oranges. Macro, on the other hand, looks at the decisions based on individuals and the economy as a whole. So think of micro as the trees and macro as the forest. All right, 4 main factors of production: land, labor, capital, entrepreneurship. Make sure that you understand the definition of capital. Capital will never, ever be money in this course. All right, capital will always be machinery and equipment. All right, so make sure you go through the book and understand those. The book also uses the terms factors of production. Sometimes they're called resources, or sometimes they're called inputs. I'm not going to comment on 4. All right, for the PPF, this is obviously increasing opportunity cost. Make sure you understand the points. I think that's kind of self-explanatory. Here, this graph here shows an increase in the production of self-driving automobiles. That could help them for various reasons, specifically because there's a new technology that only impacts self-driving automobiles and not necessarily traditional automobiles. All right. Another key point that students sometimes get lost with is a movement from J to H. They will think, oh, if we're moving from J to H, we're experiencing economic growth. Movement from J to H is just simply that the economy, the people in the economy, are demanding more traditional automobiles than self-driving automobiles. All right. And as far as where you want to be on a PPF curve, you just want to be somewhere on the curve. So as far as this course is concerned, it doesn't matter if you're at J or H, they're both equivalent. The way to determine where you want to be is going to come from the preferences of that society or community. All right. Another point that sometimes students get caught up on is the difference between a movement from G to H and L to K. All right. If you move from H to G, let's do that instead. G to H or H to G. If you move from H to G, this is because you actually lost resources, land, labor, capital, and entrepreneurship. All right. You lost them. For example, you lost them due to a hurricane. All right. So you are producing less goods. All right. You're producing less self-driving automobiles and traditional automobiles. The difference here between K and L is you didn't lose anything. You still have those resources, you're just not utilizing them. And if you're not utilizing them, meaning there's machinery and equipment laying around, most likely you have people who are also not working. So that L, or points inside the PPF, normally represent unemployment. The reason you want to make note of this right now is because later on in Module 3, when we start going over aggregate supply, aggregate demand, we're going to talk about unemployment and how it relates to the PPF curve again. All right, on this problem here, there is a video inside of the module. Feel free to watch it. If not, I'm going to go ahead and set it up here. The question's asking you to calculate the opportunity cost. There are basically 3 steps to calculating opportunity cost. First thing you want to do is set whatever they are talking to equal to each other. Now, because this is a straight line, this would be constant opportunity cost. The ones that we looked up earlier, those were increasing opportunity cost because they were bowed out to the curve. I'm sorry, bowed out to the origin. And in the video regarding why it's bowed out, both economists speak specifically to the fact that resources are very specialized and they're not easily interchangeable. So here we're assuming that whatever resources it takes to produce roses also takes the same resources to produce orchids. Not exactly a 1-to-1 ratio, because again, you can see that the slope is not 1-to-1. Had it been, it would have been 200 to 200, right? Instead, we have a slope here of rise 200 over 80, all right? And so the slope is going to be constant no matter where you are inside of this PPF curve, all right? So I am, I don't know, anywhere in here, it won't make a difference. All right. So to solve this problem, step one, right? And I could either set 200 roses equal to 80 orchids, or I could come over here to this point here and say 160 equal to 20, or 120 equal to 40, 80 equal to 60, or 40 equal to 80. So you take the 2 points, whatever you want to be, and I like to use the endpoints on a constant. Now, if it's increasing opportunity cost, do not use the endpoints. Use whatever points they're talking about, because in those examples, the opportunity cost is going to be changing. All right, so here you're going to set 200 roses equal to 80 orchids. And what that means is they could either produce 200 roses or 80 orchids. You want to solve for roses in terms of orchids, and you want to solve for orchids in terms of roses. And so if I divide both sides by 200, I'm just left with roses. I'm just going to leave an R, is going to be equal to 80 divided by 200. Oh, that's my orchids. So R is going to be equal to 80 over 20, which is going to come down to 2/5. 2/5 of an orchid. And what that means is for every rose you produce, you're giving up 2/5 of a dozen orchids. All right, to figure out what orchids are in terms of roses, what's nice about these problems is that because I only have two goods, they're reciprocals of each other. And what I mean by that is if you wanted to figure out what orchids are, you just set it equal to 5 halves a rose. All right, so the question asks here, what is the opportunity cost of 200 roses? Well, it's going to be 80 orchids. In the time that it took me to produce 200 orchids, roses, I could have produced 80 orchids. Well, what's the opportunity cost of a rose? For every rose I make, I'm giving up the chance to make 2/5 of a dozen orchids. For every orchid I make, I'm giving up 5 halves of a rose. So step one, set them equal to each other. Step two, solve for them in terms of each other. And that comes in handy when we start talking about comparative advantage. Explain if the opportunity cost of the PPF is increasing or constant. It's going to be constant, I said earlier, because if you had, I used 200 to 80, but if I had used 200 to 80 or 160 to 20 or 120 to 40, any of those points, I would have seen that the slope was exactly the same there, which is your change in Y over your change in X. For a increasing opportunity cost, you want to look specifically at those points. So had this been increasing opportunity cost, it would have had to say, what's the opportunity cost between 120 and 160? All right? Or what's the opportunity cost between 40 and 80? Because on those, if opportunity cost is nothing more than the slope is going to be different depending on where you are. So here, I've got a flatter slope, and here a steeper slope, all right? So opportunity cost would be increasing. But you'd use the same steps for both. Okay. All right, number 8, for this one, the explanation of how she explains it in the video, excellent. And the point they talks about low-hanging fruit, I completely agree with that. You've already heard it, so I'm not going to repeat it. Explain whether it is possible for a country to have absolute advantage in the production of a product without having a apparent advantage in the production of the product. All right, so for number 9, let's use this problem here to solve that one. All right, so let's following our steps. I'm going to have Cambodia. All right, in Cambodia, they can either produce 15 handbags or they can produce 3 jackets. All right, which means 1 handbag is going to be equivalent to, meaning if I am producing a handbag, how many jackets am I giving up the opportunity to make? Divide both sides by 15, and I'm going to end up with 1 handbag is going to be equal to 1/5 of a jacket. all right? Or you could put it 0.2, which means that one jacket, let me just put J, is going to be equal to reciprocals of each other, 5 handbags. So if they are producing a jacket, they're giving up the opportunity to make 5 handbags. All right, let's look at Thailand. All right, Thailand, on the other hand, could be producing 24 handbags, or they could be producing 6 jackets. All right, same thing here. I'm going to solve for H in terms of J, divide both sides by 24. I'm going to end up with H is going to be equal to 1/4 of a jacket, which means that a jacket is going to be equal to 4 handbags. All right, so step number 1, set whatever points are equal to each other. Again, because this is constant, all right, opportunity cost, I can set these 2 points equal to each other. If they were increasing opportunity costs, like I showed you earlier, you would set those specific points together, all right? Step 1, set them equal to each other. Step 2, solve for comparative advantage. Step 3, I like to call comparative advantage comparative lower opportunity advantage, so that you understand to figure out who has a comparative advantage in something, you have to know what their opportunity costs are, and whoever has a lower opportunity cost. So here, who produces handbags cheaper? So if we look here, Cambodia is 1/5 of a jacket versus Thailand, which is 1/4 of a jacket. 1/5 is smaller than 1/4, so we want Cambodia here to focus on jackets, and we want Thailand to focus on handbags, right? Notice how I didn't even look here to see if Thailand should focus on handbags. All right, I don't have to because it's comparative advantage. And just like saying when you're comparing two things, if I swim better than I run, I cannot run better than I swim. So the question earlier was, can a country have an absolute advantage and yet not have a comparative advantage in a specific good? Absolutely. Here, Thailand can outproduce Cambodia in both goods. And I know that because if I had graphed them, which is probably step 1, all right, if I graphed them here and I had handbags on this axis and jackets on this axis, Cambodia would have been handbags, let me put here 15, all right, 1, 5. Thailand would have been 24. All right, for jackets, 3 and 6. All right, and so if I say 15 to 3 here, this is Cambodia, this is Thailand. Obviously, Thailand has a absolute advantage. All right, that's Thailand. Let me put a T here. All right, they have an absolute advantage, but Thailand does not have a comparative advantage in jackets simply because Thailand has an absolute advantage. They don't have a comparative advantage in handbags simply because they have a higher opportunity cost. So if they're producing a handbag, they're giving up 1/5 of a jacket. Therefore, they have a lower opportunity cost when it comes to jackets. So they should focus primarily on jackets. So what you'll end up with is Cambodia will do handbags. So the society will end up with 24 handbags, and we'll end up with Thailand doing nothing but jackets, and Thailand will be producing 6 jackets. And I think I connected these wrong, 24 to 6. Thailand, Cambodia will be doing handbags. Cambodia will be doing handbags. Cambodia can produce 15, sorry. Cambodia can produce 15 handbags. All right, so Cambodia will be producing handbags and Thailand will be producing jackets. So we'll end up with Cambodia doing handbags and Thailand doing jackets. Okay, let me clear this. All right, so again, follow the steps. Step 1, draw your PPF. Step 2, calculate, set the 2 points equal to each other. If it is an increasing opportunity cost, just do those specific points. If it is constant, you can solve it the way I did just now. All right, not going to repeat 11, 12, Cerebus paribus. The reason we want to invoke Cerebus paribus, I do want to talk about that, is because if we don't, then we won't get the outcome that we want. All right, so these are all economic models. We are given the assumptions or the rules for them. For example, a change in income will always cause, if it's a normal good, the demand curve to shift to the right, right? That is the person who created the model, says that's how the model works. So you need to memorize the determinants of demand and supply on the learning objective sheets. I gave you kind of a guide to rates and heights, like how to memorize them. And the reason why that's important is because sometimes what I'll hear students say is, for an example, the problem will say there's an increase in income, all right? And people will say, oh, well, then suppliers are going to come to the table with more. That's not necessarily true, because an increase in supply is not affected by the income of consumers. Just because people are willing and able to buy something doesn't mean that suppliers are going to have the resources for it. So that's why we say Cerebus paribus. So if it says there's an increase in income, do not automatically assume now that suppliers are going to now bring more whatever it is, whatever the good is, widgets, to the table. All right, so you have to know to solve these problems. The very first step that you want to do is supply and demand problem. Step 1, always draw. All right, you have to draw and label. All right, and specifically equilibrium. All right, and I know you all know what equilibrium is. It's where the supply curve intersects the demand curve. There's a video. I'm not going to repeat myself on that one. All right, step 2, determine whatever the change is. Is it a consumer issue or a producer issue? Right? And you'll know those because we have a list of what the things are that shift the demand curve, as well as what shifts the supply curve. So does it affect demand or supply? Step 3, determine the direction. All right, is it going to be an increase or a decrease? And that's what I think problem after this one was sort of asking you. 14, draw a demand curve, label it D1 on the graph. All right, so we're going to determine, is it a demand issue or supply? Then step 3, direction. And then step 4, let me sort of come down here. After you determine what direction, step 4, move the curve. All right, if it's going to actually shift the curve, move the curve. And then step 5, label the new equilibrium, price, and quantity. All right. All right, so these are my steps. Let me kind of move this one down. Let's see if we can do some of these problems. All right. I'm going to skip over 14 because those are included. All right, make sure you understand the difference between an inferior good and normal good. When you increase your income, if it's normal good, you will purchase more. All right, here, number 15 is dealing with everything that affects the supply curve. Notice a decrease in the current price of the product. Number E will not cause any of this because a change in the price of a specific good is going to be a change in quantity supplied. There's a distinction between quantity supplied and change in supply. Supply shifts the curves, quantity supplied moves that goes along the curves. There's a video in there. All right, I want to pop over to 18 and then I'll come back up. All right, so with 18, each one of these is going to vary depending on how you worked it out. All right, so here I'm going to go draw my curve. First thing, draw and label equilibrium. So I have a market in equilibrium. I have a supply curve. I have a demand curve. I have Q here, which is my quantity. I have the price. This is equilibrium, right? This is going to be quantity because it's the horizontal axis. This is price. And notice they're both following the law of demand and the law of supply. Law of demand says as the price is decreasing, quantity demanded is going to increase, and that's what's happening here. And the law of supply says as the price increases, quantity supply is going to increase. All right, so step 2, is it a demand or a supply issue? Remember when you use ceteris paribus 2? So population decreases, that's going to be a demand issue. So that's going to be a decrease in demand. And I'm also at the same time going to have production increases. That's going to be an increase in supply. All right, so what that means over here is what direction. I've already determined that, and then I need to move the curve. So if this is my original demand curve right here, and this is my original supply, I'm just going to call this D. I'm going to call this S, and so the answers all vary. All right, a population decreases means the demand curve is going to shift to the left. Notice I didn't tell you anything about which is going to be a larger change. So you may have done a small change. So your graphs will look different from mine. And there's also, and I'm going to label this one D1. And the year is also an increase in the supply curve. So I'm going to say, let's say the supply barely moved out. All right. S sub 1, make sure that you are, when you are graphing these for the exam, you're not going to have to turn in your graphs, but you're going to have to answer the question correctly. So on your paper, you'll be allowed to use scratch paper, clean sheet of scratch paper. Make sure you put that this is the new equilibrium price. All right, and this would not be a good exam question simply because I didn't tell you which change is greater. All right, make sure you put in here your new quantity. So the way I drew the graph here, what I can say is because of these two changes, the price fell as well as quantity. Because there was a decrease in demand, a huge decrease in demand, and a small increase in supply, we find out that the price is decreased as well as the quantity has decreased also. All right, you may have drawn them out reverse and had a larger decrease in supply, so you'll get a completely different answer from me. So it'll depend on what you wrote down. Let me undo this. All right, we're going to go back to our original supply and demand curve. All right, next one. On B, we find out income increases and the price of the input decreases. So if my income goes up and it is an inferior good, right, I have to know, then that means that my demand is going to decrease because I'm going to substitute into more expensive things. For example, when my income goes up, I buy less ramen noodles. I'm going to start buying more hamburgers, all right? And the price of inputs increases. If the price of inputs increases, is that a demand issue or a supply issue? Supply. All right, and if price of inputs goes up, what direction? It's going to be a decrease in supply. Because their costs have gone up, we're going to see a decrease in supply. What that means, I'm going to have here, I'm going to have demand going down and supply going down. So here, you would draw your demand curve. And let's say this time I want, I'm doing both the same. So I'm going to have D1 here. And again, it'll depend on what your curve looks like which went out further, and the only reason we're not covering it now is that's probably something that we covered in a longer term class, so we could do more examples. All right, S sub 1 here. So make sure, again, that's why you want to label. This would be my new, right here. Let me erase this right here. All right. Okay, so where D meets S, this is my original price. All right, and this is my original quantity. All right, when the supply decreases and demand decreases, I end up here at D1 S1, which means I would say because of these two changes, ceteris paribus, meaning all other things remain the same, I'm going to see an increase in price. And at the same time, there was also going to be, this is my new equilibrium here. This is my Q1. I would also see a decrease in quantity. All right. make the distinction. Also, make sure you understand where D1 intersects S. This point here means absolutely nothing. You want it because, and the reason it means nothing is because we don't actually have that condition. What we have is a decrease in demand and a decrease in supply, which means this supply curve is no longer relevant. So make sure you are labeling as you are doing these problems, or else you will tend to get confused. All right. And label everything that you can. I just see people who label just tend to do better. I'm erasing everything except for my original supply and demand. I am going to clean this up right here with my equilibrium price. All right. The number of firms in the market decreases. All right. Is that a supply or demand issue? Number of firms, that's going to be a supply issue, which means it's going to be a decrease in supply. There are fewer firms. And at the same time, and usually on my paper, I wouldn't put decrease DS, I would draw a downward arrow. All right. The number of firms in the market decreases and income decreases. If your income decreases, you're making less money, right? And this is an inferior good, you're going to buy more of it, right? When I lost my job and I made less money, I bought more ramen noodles, right? So this would be an increase in supply. So I'm going to draw a decrease in supply and an increase in supply and figure out what the new equilibrium is. So demand will shift here to D1. All right, starting to see a pattern. And an increase in supply at the same time. So I lost my job. I'm demanding less. I'm sorry. Let me undo that. It's an inferior good. So DS, I'm trying to remember what DS is, decrease in supply. So a decrease in supply is going to be a shift of the supply curve to the left. Remember, left is always less, right? Some people will look at this and say, oh, look, it looks like supply actually increased because they see the curve going from here to here. It looks like an increase, but it's not. The way you know it's not an increase is if I were to go back in, right, with the purple, and just say, okay, at this price, if this were a straight line, you can see where this price intersects this original supply curve, the quantity is going to be 10. Where this supply curve intersects, that price intersects that supply, this is going to be 5. And because of that, that means that supply has decreased. 5 is less than 10. So anytime you shift a curve to the left, whether it be supply or demand, it's going to be less. All right. So I have go back to our problem here. Number of firms in the market decreases. That's going to be a decrease in supply. So supply to S sub 1. At the same time, there's going to be an increase, and this shouldn't be a D here. This should be an increase in demand. All right, that should be an increase in demand. I'm going to increase my demand for an inferior good because my income has gone down. So D1 is going to shift over here. And what you end up with, again, next time, you want to move the curve. That should be curve here, CRUVE. All right. I have a new equilibrium. This will be my new equilibrium price. So I could say because of these two changes, the price is going to increase and quantity is going to increase as well because I am demanding more, and at the same time, the supply is going down. We will find out here when we compare for original D that we have increase in Q, right? And again, everybody's curves will vary depending on the magnitude. What I mean is how much did you change the curves? All right, consumer preferences decreases and the price of complements increases. All right, consumer preferences is a demand issue. If consumer preferences decrease, that means demand's going to decrease. And at the same time, the price of a complement increases, right? Make sure you understand these for the exams. If the price of a complement increases, all right, and so probably the best thing to do is to have a set of these in your head, all right? So for me, whenever I do complements, I always like to think of peanut butter and jelly, all right? So if the price of jelly increases, that means the quantity demanded of jelly decreases. If the price goes up, quantity demanded goes down. If it's a complement, that means the demand is going to shift back with it. So if consumer preferences change and the price of a complement increases, right? What's going to happen? Demand's going to go down for both. So if the price of a complement increases, it means quantity demanded goes down, which means that I'm buying fewer of that good. And if these two goods are complements, I'm also going to buy fewer of the complement good. So if the price of, there's an increase in peanut butter prices, my quantity demanded of peanut butter is going to go down. If I'm buying less peanut butter, I need less jelly, right? So on the exam, it'll probably be written giving you an example. The other thing that you need to recognize, we talk about rational consumers in the beginning of the book, is that do not pay much attention to if I'm talking about Colgate or Crest or Heinz or Hunt's. When I say something is a substitute, it means they are perfect substitutes. There are no differences for them. All right, so with D here, I think it was decrease. So I've got a decrease in demand, consumer preferences decreases, and the price of the complement increases, which means this just means the demand curve is going to shift back, right? So instead of moving two curves, I'm actually just going to move one curve, right? Let me show you what that would look like. If I take everything off of here, go back to my original supply and demand. All right. Consumer preferences decrease and the price of a complement increases. I think I had that here. All right. Both of them are going to cause the demand to decrease. You're going to draw your demand curve here, label it D sub 1. And here you don't have it S sub 1, so your only equilibrium, because nothing else changed, is here. So because the demand decreased, you find out, oh, look, the quantity has decreased as well as the equilibrium price. All right, the market clearing price will be less and there'll be fewer units sold, all because demand decreased without any changes to supply. All right, last one. The price of a substitute in consumption increases and the price of a substitute in production increases. All right, so price of a substitute in consumption has to do with when I am producing a good, and let's say peanut butter and jelly, whatever those happen to be. All right, so the price of a substitute in consumption increases. So if the price increases, and that's going to be an increase in the demand. And then the price, so we're going to have an increase in demand. So two goods are substitutes for each other, like let's say Heinz and Hunt's. The price of Heinz goes up, which means that if this is a substitute for the good, which is what I'm looking at in that substitute market, if the price of the substitute goes up, that means this good here, people are now going to want to demand, all right? So it's going to be an increase in demand. And at the same time, the price of a substitute in production increases. That has to do with substitute in production. Am I going to produce, I have all the resources. Do I want to produce corn or soybeans or whatever? Well, it's going to depend on where my money can make the most return on investment. So if the price of a substitute in production increases, let's say I'm producing corn. Well, we're talking about, this is ketchup, right? So my complements are, my substitutes are Heinz and Hunt's, trying to come up with an idea here. And a substitute in production means that I'm producing tomatoes, but I now have the resources to produce anything, and corn, soybeans are selling more. So next year I'm going to go supply soybeans or produce soybeans, which means there's going to be a decrease in supply. All right, so there's an increase in demand, and at the same time there's a decrease in supply. Cerebus paribus, what does that mean for this market of, oh, that's why it deleted. All right, here we said that my demand was going to increase. So D will go to D sub 1. And at the same time, there are less suppliers in this market. So I have demand going up and supply decreasing. So you can expect to see, this is not good for consumers, a huge change in the price. And that's why I end up with a price way up here. So the equilibrium price will increase. And equilibrium quantity here, where D1 and S1 intersect here, almost stay the same because maybe the changes are the same here, right? We'll end up right here. right? So again, it depends on how your graphs, the magnitude of them, when you are moving two curves, it's a little bit more difficult, but please get used to it. On the exam, if I specify the change, and again, I'm not going to necessarily, or in this example, but had I specified, I do want to show you one of those just in case you're wondering. The problem would have been worded something like, let's go back to number one. The population decreases and production increases. So we already know that this is going to be a decrease in demand and an increase in supply. The problem would have had to tell you that the population decrease is larger than, all right, this is larger than the productivity increase. So that means that demand, the change in demand is going to be greater than the change in supply. So what I would show here is the demand is going to be a decrease in demand. It's going to be huge. So you would shift the demand curve way out here to D sub 1. And productivity increases. That means, and I said earlier, the best change was going to be larger than the increase in supply. So let's say whenever I have that, I don't even bother to move the supply curve because it's just going to be a sliver. So I would just pop a 1 on here and say, oh, look, when that happens, when the change in demand is greater than the change in supply, what I can say is the equilibrium price will fall and the equilibrium quantity will fall. It'll fall from here to whatever this number happens to be here. All right, so that problem again will not be on the exam unless it's a bonus question, and I rarely throw bonus questions on there, or it may be on your exam depending on what semester you're taking in this class. But if you were interested in wanting to know how to solve and get a specific answer, you would have to know the magnitude of the change. All right, let me clear that off. Make sure you follow the steps. All right, and then last but not least, let me come back up. All right, want to talk to you about equilibrium. This is straight out of your book. So if you missed number 16, what I'm looking for here is for you to set it up. Make sure that you label the graphs, quantity on one axis, price on the other. Make sure you know how to read a graph. If you don't, you can look up tons of videos on Khan Academy on all these points. Remember, this would be your x-axis, this is your y-axis. Also notice, supply will never ever equal demand because the supply curve has a positive relationship between price and quantity, meaning as price goes up, quantity goes up. Demand curve has a negative relationship or inverse relationship. As the price goes up, quantity demanded goes down. All right, I know you can all spot equilibrium, but what's more important than you can spot it is why is it equilibrium, right? The reason it's going to be called equilibrium is because at that point here, where quantity supplied equals quantity demanded, there's no pressure on the market, right? Meaning that there's not a huge surplus of goods that people need to sell, right? Price controls are what we consider a market failure because we don't get to the true correct amount of price and quantity of a good because of government intervention, right? And so an economist would say that price controls cause something called dead weight loss, which I'll show you right here. So let's say I've got a supply and demand and it tells me that in equilibrium is 50. And the quantity here is going to be 200. It goes on further to tell me here if the selling price was 75. All right, so what to say that the people here arbitrarily decide to make it 75. This is not a price ceiling or a price floor, all right? The answer would be different if it were a ceiling or a price floor because at the 75, if it were a price ceiling, all right, I can't change that. Or if it's a price floor, I can't change it, right? But if the price just happens to be the big person selling it says, oh, I'm not going to sell them for 50, I'm going to sell them for 75. This is going to cause the market to be in disequilibrium. What I mean disequilibrium is that here, quantity supplied does not equal quantity demanded, all right? Quantity supplied does not equal quantity demanded. And so at a price of 75, if you're reading the graph, what I find out at a price of 75, people are not going to want, when the price goes up, there's going to be, like I said, a decrease in quantity demanded. And so this point here, meaning at a price of 75, this point is going to relate to, let's say, 100. When the price went up, consumers wanted less of the good. But when the price goes up, suppliers are willing and able to, in that production, substituted production, they're willing to supply more of this good because they can make more money, right? It doesn't ask them how much do you think you'll sell, but obviously the supply curve, they're willing to supply as much as they can, right? Assuming they can sell as many as they want. So at a price of 75, suppliers are going to come to the market with, let's say, this is 100, 200, 300. All right, and so when we talked about equilibrium earlier, what that meant was at a price of 75, I'm going to end up with quantity supplied is going to be equal to, slide over here and come down to read this graph, 300. Quantity demanded is going to be equal to quantity demanded at the price of 75 is going to be equal to 100. You're going to end up with a surplus of 200. All right, if you want to know how many are actually going to sell, the short side always wins. So if I have suppliers coming with 300 units, people only want to buy 100 of them. That means that there's only going to be 100 transactions, all right, the short side here, and I'll end up with a surplus of 200. All right, explain what would happen if the selling price were 25. So 25, the numbers are going to be reversed. So at a price of 25, I have to figure out, well, what does that do to quantity supplied and quantity demanded? At a price of 25, and I'm making up these numbers here, quantity demanded is going to be some number, right? And you could have just said that quantity supplied would be less than quantity demanded. It'd be true, but I like to actually use numbers. At a price of 25, because the price is so low, when the price goes down, quantity demanded is going to go up, which again, this is an inverse relationship, so it looks like it's going down, but it's actually going up. Quantity demanded is going to be equal to 300. Quantity supplied, because it's no longer profitable in this market, suppliers are going to get into another market. They're going to flip over and start using their land, labor, capital, entrepreneurship to produce another good. Quantity supplied here at a price of 25 is only going to be 100. So down here, I'm going to end up with a shortage. So when the price is arbitrarily set below the equilibrium, you end up here with a shortage. So 300 people want to buy the good. I only have 100. How many goods will actually be purchased? The answer is going to be 100. All right. I'll end up with a shortage of 200. The book talks about this is how you end up with a black market, right? In economics, we don't consider this necessarily efficient, all right? So let's look at it from a perspective of a price ceiling and price floor. Because in this example, we'd say the markets are in disequilibrium, but I have the advantage of if there is a shortage, we can let the price rise, right? There'll be auctions to increase the price. If there is a price ceiling or a price floor, make sure you understand the difference between binding and non-binding. So let's say they had come in and decided to put a $25, all right, I'm gonna make it binding just because I think I've explained non-binding enough. All right, for this to be binding, right, regarding a price or a floor, if it is a floor, it means that the good has to sell for 25. Well, in the market, it's selling for 50. So this would be a non-binding floor, but I want to make it a binding, so I said I was going to make it a ceiling. All right, ceiling is meant to help consumers. And so what that means is if this is a ceiling, it is a binding ceiling because it says you cannot charge more than 25. So what I like to do, step one, I like to draw whatever the line is, and I draw the line so that I can recognize this is a binding, not binding, but like a mandated line, as opposed to when the prices were arbitrarily decided by suppliers. And I like to draw an arrow. So if this is a ceiling, what it means is that you cannot charge more than. So step one, draw it. Step two, indicate, right, where you are. It's a price ceiling, therefore you must charge below the ceiling, right? Step two, compare, right? Where is my equilibrium? My equilibrium is above the ceiling, therefore this would be considered binding. There's going to be an issue, which means that quantity supplied will not equal quantity demanded. All right, so at a $25 price ceiling, I'm going to end up here with a shortage. All right, that's going to cause a dead weight loss. What that means is I'm not going to sell the 200 units I sold previously because, again, we're only going to end up selling 100. So what's going to happen is this area here, this triangle here, would be what we consider dead weight loss. All right, because I have a ceiling supposedly to help consumers, though, consumer surplus changes. So previously, consumer surplus would have been, all right, this entire area here, right, this triangle. But now that the price has been decreased, the consumers are going to lose this section here to deadweight loss. That'd be consumer deadweight loss. But they are going to keep this section they had before, but they're also going to gain this section here. All right, this now becomes consumer surplus. This was producer surplus before. And producer surplus will only be left with this here. So after a bonding price ceiling, and this would be consumer surplus. But the issue here is that consumer surplus plus producer surplus is not as much as it would have been in equilibrium. In equilibrium, we would have had this entire area plus this entire area. These sales or this surplus that would have happened here doesn't even occur anymore. This is all deadweight loss. And so a lot of times what we say in economics is that when there are no price controls, there is zero deadweight loss, right? So make sure you understand price controls. Let me clear this. And shortages and surpluses. Just wanted to point out this problem here was asking, I saw a couple people had problems with this one. If it tells you that the market price for lemongrass is $4, you're going to draw out your supply curve. Remember, you want to label everything. Graph without labels means nothing. Quantity, price. And it tells me I have a demand curve. And it told me that at demand, quantity demanded is 0 when the price is 30, right? So if this is 0 right here for quantity, this would mean that at this price here, this is a 0. This point is 0.30 if you were graphing it. But it also tells me that the market price or equilibrium price happens to be $4. And at $4, it tells me that the quantity demanded, this point here, is 1,500. Right? You need those numbers in order to calculate consumer surplus. And the idea of consumer surplus as per the book is the demand curve is what people are willing and able to purchase. All right? This person was willing to pay up to $30 or up to $29, but they only had to pay $4. So that area from here to here is what we call consumer surplus. And so if we added that up among every single person who purchased it, all the 1,500, we could do that, or we could just take the area of the triangle. And this is not really explained in the book, but it is in the video, and it is on the exam, and I have a couple of sample problems. So the formula of a triangle is going to be 1/2 base times height. And so therefore, you're going to have 30 minus 4. All right, 1/2. And then to figure out, that's this area here, to figure out the height here, I know that this is 0 and this is 1,500, so this is going to be 1,500. All right, if I take half of the 26 times the 1,300 times 1,500, I'm going to end up with, let me get a pencil, 19,500. All right, that 19,500, it's in what we call utils. All right, so it's not really necessarily a number. We just say that the consumer surplus here would have been 19,500. All right, so be able to calculate consumer surplus, producer surplus, or deadweight loss. Usually it's just messing with the triangles. All right, what is the difference between price ceiling and price floor? You already have that. Don't want to waste your time. And then the last one here, just sort of want to point it out. If this is my price floor, this price floor is set below the equilibrium, therefore it is non-binding. So what this says is the price must be, what I said, you draw it. Price floor means that it has to be, equilibrium has to be above. Draw your arrow above. Is equilibrium in that area? Yes, it is. Therefore, it is not binding. It is not an issue. So the markets will still clear at this price, and there will be no deadweight loss. All right, if you have any questions, let me know.